Hello, I'm Dr. Papiya Bhattacharjee. In this problem, we have a function and we have to find the horizontal asymptote to the graph of the function if there is any. So, you have to find horizontal asymptote. Okay, so how do we do that? Notice that this function is a rational function. So, it is a polynomial over a polynomial. And there is a nice way of figuring out what is a horizontal asymptote to the graph of a rational function. So, let me remind you of that first. Suppose we have a rational function and it is written as, say, polynomial px over another polynomial qx. And there are three different rules. One of them says that if you consider the degree of px and it turns out that the degree of px is equal to the degree of qx, so they have the same degree, then the line, horizontal asymptote is a horizontal line, and the line y equals a constant. What is that constant? It is the leading coefficient of p over the leading coefficient of q. That constant will give you the horizontal asymptote to the graph of that function. So, let us go back here and try to understand this function that we have. So, it is rational, and so the numerator function is our px and the denominator function is qx. So, let us figure out what is the degree of p and what is the degree of q. So, the degree of px, notice that the highest degree is, there is just x. So, it means that x has a power of 1. So, the degree is 1. What about q? Same thing, right? X has a power 1. So, the degree of q is also 1. And so, we have this situation for this problem. The degree of p is equal to degree of q. So, what is a horizontal asymptote to this curve? Let us figure out. We have to take the leading coefficient of p, and the leading coefficient is the 4. And then we have to take the leading coefficient of q and divide by it, which is 2. And this is just 2. So, y equals 2 is a horizontal asymptote. To this function. So, that's pretty straightforward using the fact that we have for a general rational function. Now, there is another way of figuring out the horizontal asymptote without knowing this fact, and that way is just directly evaluating the limit, because we know what is horizontal asymptote to a function, to the graph of a function. It is the line that the function approaches to as x is approaching to infinity or negative infinity. So, why don't we take our function and evaluate the limit as x approaches to infinity of this function and see if we can get a value, and that will give us a horizontal asymptote as well. All right. So, let us write down the function. It is 4x minus 3 over 2x plus 1. Now, the question is, how do we evaluate this limit? Now, notice there is a very nice technique we can apply whenever we have a rational function. So, you have a polynomial over polynomial. Okay? What you do is, you consider the highest degree that we have in the numerator and the denominator. So, look at both these polynomials separately and figure out the highest degree. Well, we already know that the degree is 1 for both the numerator and the denominator. So you take the expression x to the power 1 and divide both numerator and denominator by x. So you're dividing by x to the power the highest degree, whichever it is from numerator and denominator. So you do the same in the denominator. Okay? And then we just simplify a little bit and rewrite the two expressions. So notice in the numerator we are going to divide 4x over x. So you get 4, and then you get 3 over x with a minus sign. Denominator, same thing, you're just dividing x to both terms. So 2x over x is 2 plus 1 over x. Now why did we do this? Because as x approaches to infinity, we know that the denominator of these two expressions, where there is x, that is getting big, and so the whole expression is getting small, which means that the 3 over x will go to 0, 1 over x will go to 0, and the constant will remain as it is. So we will get 4 minus 0 over 2 plus 0, which is 4 over 2, which is 2. And that is our answer, right? Y equals 2 is a horizontal asymptote to the graph of this function. But I tried to show you another way of obtaining that result. Thank you.